So now I want to start graphing this crazy looking function, and I'm going to tell you guys off the bat, if you looked at the other video, you know why I moved the 4 to over here. It's not a requirement, it just helps keep me in the right frame of mind. But honestly, with a trig function, the first thing I got to figure out is where does this new period begin or end? We know there'll be some kind of like shift going on because of this, and we know it's going to be like scrunched up or like stretched out because of the 2 pi. We just got to figure out what that new period is. So our first step before we do anything else is to first recognize that the typical period for a cosine starts at 0 and goes to 2 pi. So I just need to figure out which values of x make this inside equal 0 and which value of x makes this inside equal 2 pi. So my very first step is to set that inside equal to 0, solve this, set it equal to 2 pi, and solve this. I'm going to go through the steps on this one pretty carefully, but I'm going to pause my recording and just solve this one out. This one's relatively straightforward. I want you guys to try it yourself as well. And then if it doesn't go well, I'll go through this in detail. This one's tougher. So anything I do over here, you can apply to over here to figure out what went wrong. But let me pause. You should pause and solve it yourself. Because when you, like, in a second, it's going to be all there. So if you solve the left side correctly, you should get x equals to negative 1/8. And if you didn't quite get there, you don't follow all these steps, listen to how I solve this more challenging problem, and see if you can figure this out. A couple things I'll say is, like, anytime I'm dealing with fractions and all these pi's, I do my best to not let the pi's freak me out. They're usually just baggage you have to carry around and keep track of, but we're not going to think too much about them. We're just going to carry them around. I do know that for the first step of this equation, I'm going to have to subtract the pi over 4, which is a fraction, and it will be from over here. So I'm going to want to start probably by thinking about this as something over 4. So right now it's 2 pi over 1. Let's make it something over 4, top and bottom by 4. I'll change this so it has a common denominator and think of it as 8 pi over 4. I don't always write it down, but I always think it. So I'll subtract this pi over 4 from both sides. And again, so much static, so much like things to think about. We got fractions going on here, we got pi's. I'm not going to worry about it. Here's why. I know the denominators match, and they're 4, so I'm not going to worry about them. Both of these terms have a pi, so they're like terms, so I can combine them, so I won't worry about that. The only calculation I'm thinking about is, when I'm thinking about what is 8 pi over 4 minus pi over 4, I'm really just thinking about what's 8 minus 1. And then I'm carrying around the pi and the 4 with me. And I really make a conscious effort to be like, I'm ignoring the 4, I'm ignoring the pi. I've got to think about 8 minus 1. 8 minus 1 equals 7. And then it's pi over 4. Like, you just kind of tack it on there. So this side becomes 7 pi over 4. And this, all that's left over here is 2 pi over x. The other thing I'm going to mention that you may not have thought about over here, with these types of problems, I'm not going to think so much about dividing by 2 pi, but I'm going to multiply by a reciprocal. It's a much more effective way when you have to work with fractions, and sometimes you just have to work with them. Think about, don't divide in equations, multiply by reciprocals. So I'm going to take 1 over 2 pi on both sides. Whoa! Hit the mouse button by mistake. These will knock each other out, leaving just x. And of course, this pi knocks out this pi, leaving me with 7 times 1 on top and 4 times 2 on the bottom. That's 8. So what I've just figured out is that if x equals negative 1/8, I got the cosine of 0. And if x equals 7/8, I got the cosine of 2 pi. I've got the beginning and the end of one full period. And for all these problems, we're only going to do one full period. Well, we won't do 2. We could. I could also set it equal to negative 2 pi, but let's not worry about it. I'm going to pause and draw a nice, I'm going to put this on a number line so it's nice and scaled out and talk about what's left. But I messed it up in my last video, so I'm going to pause and do it correctly. Hold up. Now we have this task of taking this full period, breaking it in half, and then breaking those halves in half. Most students are not careful when they want to put things to scale, so I'm going to talk about a mathematical way to do this. And here's the thing I want to mention. A couple things. Both of these numbers are over 8. If they didn't have common denominators, if somehow they didn't have common denominators, I would make them have common denominators. Because I just want to focus on the halfway point of the numerators. So here's what I'm trying to say. if I'm trying to find halfway between -1/8 and 7/8, I don't know where that lands on your ears, but if I was a junior in high school, I'd be a little bit confused by that. If the teacher asked me to figure out what was halfway between -1 and 7, I would still be kind of like, I'm not sure. I'd start like picturing a number line, moving stuff around. And then somewhere like around your age, I was like, wait a second. If I just take the average of two numbers, that's the halfway point. If I just add them up and divide by 2, that's the halfway point. It's the average. And the thing is, if I can look at -1 and 7, and I can add that up and get 6, and divide that by 2 to get 3, 3 is definitely halfway between -1 and 7. And that means that 3/8 is definitely halfway between 7/8 and -1/8, because we're just dividing them all by 8. So this is why common denominators are so phenomenal. Once you have them, you just need to carry them around. And then later on, you should reduce if possible. But I'm going to figure out what's halfway between -1 and 7 by adding those and dividing by 2. And I'll just put everything over 8. So this halfway point is going to be at 3/8. And then I'll apply the same trick here. I want to figure out what's halfway between these two guys. So I'll kind of like ignore the 8. They're both over 8. Great. If I add those up and divide by 2, 3 plus -1 is 2. Divided by 2 is 1. So 1/8 is that halfway point. And now I'm looking for a pattern in the numerators because the denominators are all the same. So it goes from -1 to 1 to 3. So it looks like it's going up by 2s. The numerator is going up by 2s. So 5/8 is the next halfway point, and then just make sure the pattern continues up by 2s to 1, up by 2 to 3, up by 2 to 5, up by 2 to 7. Yay. I did it. I did it! So I've taken care of this whole kit and caboodle. This whole kit and caboodle by setting equal to 0 and finding the new starting point, setting it equal to 2 pi and finding the new ending point, finding the halfway mark, finding the half of the half. Everything else, not too bad. What happens? This 4 moves the whole graph up 4 units. Now I didn't give myself enough space on this paper. So I'm going to call this 2, and this 4, and this 6. And for some reason, every time I draw a 4 with this pen, it looks like a creepy 9. I don't know why that happens. I'm just not good at drawing 4s with this. So the whole graph, that line, for a cosine graph usually is here at 0, but the whole graph's moving up 4. So I'm going to draw what we call a new 0 line. It's going to go through at 4. So the line that's normally at 0, the x-axis is shifting up 2 units. That's my new 0 line. Anytime cosine was 0, I'll be on that line. I know that there's an amplitude of -2. Like it's stretched by -2. So from this new 0 line, I'm going to go up 2, I'm going to go down 2. Let's put this in pink. I'm going to always be 2 above or 2 below. And please act like these lines are in the correct place. I don't know if you know how hard it is to draw the tablet. Of course you know how. So my whole cosine function is going to be between these 2 pink lines. It's going to hit that new 0 line, that new green 0 line. And normally, now I'm just going to go ahead and put the different points at these different x and y values. Cosine normally starts by going up 1. So this is the normal starting point. It's moved over. Normally it would go up 1. But this is a -2, so it'll go down. And it goes down 2. So it goes to the max value. Then it goes to the 0 line. Then it goes up. Then it goes back to the 0 line. And then it goes back down. This is concave up. This is concave down. This is concave down. This is concave up. We've taken the whole graph. We've shifted it over. We've moved it up. We've flipped it upside down. It's a lot. No one's going to feel like they know what they're doing. But you do know what you're doing. You get out your graphic calculator. You're going to check it. Put it on decimals. Adjust the units so you can see what you're getting. That's basically it. We'll do one more together. It's going to be epic.